the third class in the Intro to Object-Oriented Programming course where we're using Java. Today's class, what we're going to do is we're going to focus on building classes like we've done in all the other classes that we've had. But today we're going to focus on a relationship between these classes called, basically we're going to set up this parent-child relationship between the classes. So we're going to create a class, as this drawing shows. We have a person, and then we'll say an employee extends a person. Or another way to look at it is an employee is a person, or a student is a person. So we're going to do the, we're going to look at the is a relationship, and and we're going to do that using using an employee class. Now just food for thought for everyone. Remember, next week number 4 in the course is our first test. During the test, things that are fair game are basically anything that was in the previous course. So creating a class, creating constructors, validating inputs, generating exceptions, creating methods. So, you know, make sure you understand how method headers work, what the return types are, what arguments are, the basic loop structures, the primitive data types, and creating some classes, and playing with strings. Test to be practical. It's open book. You can use anything you want in the test. What you're not allowed to do is go online and research or communicate with other people during the test. And it's going to be short, like maybe an hour. Maybe we'll build 1 or 2 classes. Okay, so let's get right to it. So the idea here, what we want to build today is this idea. This we're looking at is a UML class diagram. And what we're going to build initially is called the employee class. So you can see it up here at the top. And the idea is every employee has a first name, a last name, a social insurance number, some date of birth, an employee number. And you know, we're going to have methods to set the birthday, get the first name, last name, get the social insurance number, all these good things. So every employee has those attributes. They're common, whether you're paid by the hour, paid by commission, whether you have base pay, whatever. Those elements are common. So then what we're going to do is we'll then extend this. We're going to create an hourly employee that extends our employee class. And what that means is the hourly employee will get all of the attributes and all of the methods of the employee class. And they will also get these new specialized features. So for example, an hourly employee, we have to be able to know how much they get paid per hour. And we need to know how many hours they've worked. What's not showing in this diagram is that we're also going to create a class called Paycheck. And the idea with the Paycheck is that it'll keep track of how much the person earned and literally create all the elements of a paycheck for us. So let's get right to it. Let's go into, I'm going to go into NetBeans. And I will put all of this onto GitHub for us as well, so that you can follow along. Let's let this launch here. Okay. Okay, I'm on it. Here we go. File. New project. So we'll build a new Java application. And I'm just going to call this one Winter 17, January 25th. I guess I've already created that one. All right, part 2. Okay. And again, I'm going to put this all onto GitHub for us. So what I'll do is I will go down and I'll go to versioning. I'll initialize the Git repository. Okay. And then I will go into GitHub. And here I need to create a new repository on the cloud side. And I'm going to call this COMP1008-Week 3. And I'll take my location for this new repository. I'll come in here and let's do a commit. Let's call it the initial commit. And then team remote push. And in here, I can put in my new repository, select the master branch, finish up. Okay, so we have this class. We're not going to do anything with it right now. So first thing we're going to do is build out our employee class. So class employee. And I'm going to keep going back to this design here. So the idea is we want to design out our classes before we actually try to implement them. It makes our life a lot easier. So I'm going to need instance variables to hold first name, last name, social insurance number, date of birth, and an employee number. Okay, so private. So a good data type to hold a name would be a string. So I'm going to say first name, last name, and private int social insurance number. I'm going to use a class called local date to store my date of birth. Now the reason for that is there are a lot of ways to store dates of birth in Java. Local date is a newer one, and the beautiful thing about it is it takes into account different time zones. And as our applications become more and more broad-reaching and global in nature, the ability to handle time zones is fantastic. The other nice thing about this is what we're doing right now is we're creating the model for an employee. Eventually, we're going to hook this up to build a GUI, a graphical user interface. And the date picker in JavaFX returns a local date object. So by using local date here, when we go and get that object for the graphical user interface, it can populate this directly. We don't have to do any conversions. Now it's underlined because in Java, they don't include every single class in every single program. They include the basics. Otherwise, the programs would be much larger than they really need to be. So we need to explicitly tell it to use this class. And I'm going to do that by going to the light bulb here, left click, and add the import. And you can see the import came up here, and now the error is gone down here. Okay. Now the other thing it said we needed was the idea of an employee number. So I'm going to say private int employee number. And I heard something a little bit different than we've done. I'm going to use private static int next employee number. And I'll even give that a starting point. I'm going to say is equal to 10,001. So the idea of having a static variable here is that all instances of employees will refer to this. Right? So when we have an instance of an employee, this will be unique. These will all be unique for each specific employee. But all employees, because this is static, all employees share this one. And when we do our constructor, we'll increment this each time we create a new employee. Okay, so it looks like we've got most things here. So let's create our constructor. So again, the constructor, it'll have the exact same name as our class. And by default, this is the default constructor. It creates a new instance of an object, but it doesn't really set anything. But I want to be able to set the first name, last name, social insurance number, date of birth. So I need to pass that information in. So I'm going to say string first, string last. And in fact, actually, what I'm going to do, all editors have this. I'm going to right click. I'm going to say insert the code, insert the constructor. And let's do all of these things except for the employee number. Everything will be passed in. The employee number, I'm going to set that automatically. And when you do that, it actually creates the constructor for us. I'm going to let's move that along a little bit so it's easier to see. Okay. Oh, I guess I forgot to do last name. Now, a common question is, why do we have the word this here? What does that do? Well, you see, if I double click on this, see how it's highlighting this argument, right? So this argument first name, it's passed into our method. It is local. It's said to be local to our method. It basically only exists here. So whatever value is brought in here only exists within this particular specialized method called a constructor. But what I want to do is at the class level, I want to set this first name attribute. So what I'm doing is I say this, meaning this class. So go to the class level, and then I'm naming my variable that I want. So you see when I select this, now it's highlighting that one. It's not highlighting this one. Conversely, if I go over here, these two are highlighted, right? So although they have the exact same name, they both say first name, they're actually referring to two physically different spots in memory. Okay, and then in terms of the employee number, what I'm going to say is the employee number equal to the next employee number. And then I'll increment the next employee number. So we get another employee. This will be +1. This way, no employees can get the exact same number. Okay, so that's our constructor. We can run this now, and we can get an instance of an employee. In fact, we can test it. So we can go here, and we can say employee, call it employee 1 equals new employee Redstone. Make this a little bigger so you can see it. Fred. Number 1, 2, 3, 4. And we'll do a local date of. And he's born 1956. Let's see here. Let's make up a date. Fred. Local date of 1956, March 12th, let's say. And then if I go to print out my object, employee 1. It's going to be a very boring program, but go to print it out. I'm just running it here. It says our first employee is, and we get this, kind of internal representation of employee. It doesn't represent itself very well as a string at this point in time, but that's okay. We'll create our own toString method. So let's go back into our employee class. And if I go back to our class diagram here, we can see there's a method called setBirthday. And although I didn't explicitly mention this, the idea is employees need to be of a certain age. So I'm going to say employees that are younger than 14, fortunately, they're too young to work for our company. And if they're older than 90, they're too old to work for our company. So let's say this method will validate that an employee is the correct age to work for our company. Okay. The idea here is we'll take in a local date object, okay? And then we can compare local date objects. So I can actually create another one. I can say local date, and I'm going to call it today equals local date dot now. Okay. So by doing this, I now have a local date object that represents today, whenever today is, right? If I run the program 2 years from now, it still represents that specific day, and the date of birth, which for a person shouldn't change. And then I can do something. I can say age is equal to the period between date of birth and today. And then period objects, you can see there's different things, the amount of days, the amount of months, the amount of years. Well, let's do that. I'll get the amount of years. So what this does is it figures out how many years there are between the date of birth and today. And I can say if age is let's do greater than or equal to 14, and age is less than or equal to 90. So if you're between 14 and 90, then I'm going to say date of birth is equal to the DOB. That should be 50. And if it's not, I'm going to throw new illegal argument exception. When we build a GUI, we can actually handle, like, we can do a try and catch, and if we get this kind of an error, then we can inform our user what's going on. So because we have validation now for our birthday, rather than blindly set it here, I'm going to use this validation tool. So I'm going to say set birthday, date of birth, like so. So when we create a new instance of an employee, whatever date of birth comes into here, and then it's going to go pass down to the set birthday method where we checked if they're the right age, and then we'll set their birthday accordingly. And if they're the wrong age, then we're going to inform the user by throwing an exception. Okay. So then one of the other things we want is, for any employee, we probably want to be able to get their first name, their last name, social insurance number. So I'm going to right click here and go to insert code. And to get access to those things, not to modify them, right? Because I want to control how we modify them, but I can get, for example, the date of birth, and get the employee number, first name, last name, and maybe their social insurance number. I don't want to return the next employee number. That's something that's unique to, you may need to just keep that one within our class. So I'm going to say generate. And then you can see what happens is it creates all of these simple return methods for us, right? So you don't have to type them out. Okay, so what's left? What's left here? So we've got set birthday, get first name, last name, full name. Okay, so the last thing we have is when we ran our program, we looked at our output, we got this. And really what that's calling is a method called toString. Actually, I'm going to type that in again to show you something important. So when I touch on this, you can see a lot of things here. So first off, I can see a description of what this method is supposed to do. But I can also see the class from where it comes. See, it says java.lang.object. This is the class where this method comes from. And we're actually, all classes are a type of object. Okay, so we are inheriting this method toString from the object class. And that's why it's really, really generic. Now, let's go back in here and create our own toString method. So I'm going to say public string toString. And you can see here I get this little light bulb. And this is just a recommendation. But if I left click on it, I can add the override annotation. And what this means is I'm going to explicitly tell the compiler, override whatever the parent class or superclass has for a toString method. Use this one instead. So here, I'm going to just say return first name, a little space in, plus the last name. Save. Come back now and rerun our program. So when I rerun our program, it says our first employee is Fred Flintstone. And we could add other things here. We could say the employee number is something like this. Now when I rerun it, I can see there's our first employee. If I make a second employee, employee number 2, Arnie, and he can be a little younger than Fred, and maybe he's born January 1st, New Year's Eve. Say our second employee. Okay, so now when I run this program, I can see our first employee is Fred Flintstone. Employee number is 1001. Second employee is Barney Rubble. The employee number is 10,002. So you see, we're creating separate instances of employees, right? We have two separate objects here, and they can use any of the methods available in the employee class. And then we have this method down here that we haven't talked about yet called get paycheck. And the idea of that is I want to create a method that will allow them to receive a paycheck object. So this method will create a paycheck object for the employee. Now here I'm going to say public abstract paycheck. Now this is a little bit different than any other method we've done before. We will create a class called Paycheck in just a second. So this is underlined because that class doesn't exist. But what's different here is the word abstract. Now what abstract means is, if we look at our class diagram, okay, here we're saying employees can be hourly employees or they can be commission-based employees. And the way they're paid is different. So for example, an hourly employee, say they get $15 per hour, and then they work 20 hours, right? Then it's going to be, $15 an hour times 20 hours. They're going to get their $300 pay. Whereas a commissioned employee, they're going to generate their paycheck a different way. Here, they're going to keep selling things, right? So at the end of the month, they've sold so many dollars worth of product, and they're going to get paid, 1%, 2%, or whatever the commission rate is for their sales. So what we're doing here with this employee class is we're saying, look, I don't know how you get paid in these subclasses, but I'm going to force you to create a method that matches this pattern. Okay, and the pattern is it has to return a paycheck object, and it has to be called build paycheck, or I think in my diagram I called it get. So let's just make it consistent. Get paycheck. Okay, so let's build out a paycheck object, and if I go here and we look up, checks, images, here's just typical things on a check is pay to a certain person or company, a date, an amount, and likely there's a check number on here somewhere. Okay, I'm not going to worry about the account branch and the account numbers and all that stuff, but we'll create an amount, pay, a date, and a check number. So I'll go back here. I'm in the same package as my employee class. I'm going to say new Java class, and I'm going to call it a paycheck. Okay. And then just like before, we said, well, what are the attributes of a paycheck? Well, we have the person's, let's do an employee name. We have the employee name and maybe a memo of some sort. We have a local date object to store the date issued. We have the idea of a check number. Okay. I'm going to import my local date here, left click, add the import, build a constructor. So my constructor, I don't really need a lot of information here because I can always figure out the date. I already know the check number stuff. Oh, but I will need something for the amount. So we'll use type double for that, because that can store decimals. Okay, so we need a string for the name. We need a string. We'll do double a amount and a string for a memo. And then we can say the employee name equals the name, the amount equals the pay amount, and this dot memo equals memo. Right, so memo, notes, whatever you want to call it. So again, here the idea is I'm using this because these actually have the exact same name. So I have to put in this to say this class up here, this one, is equal to the local memo that gets passed in. Now, with paychecks, we really should validate that the amount makes sense. So this method will validate that the amount of the check is positive. Right? It wouldn't make sense to write a check for a negative amount of money. So public void set amount say if the amount is if it's less than 0, I'd argue you don't even need a paycheck if it is 0. So if the amount is less than or equal to 0, then throw new illegal exception amounts must be greater than 0. If we didn't throw an exception, then it must be valid. Once you've written a check, you shouldn't be changing the amount. So I'm going to make that private. And then up here, we can say set the amount for the check. We can use the usual getters and setters. So I'm just going to insert code getters. So we can get the amount, the check number, the date it was issued. Don't need that. So everything else is good. Generate, and it creates this code for us, sort of stubs it out. If I go back to my employee class and hit save, now this error is gone because we have a paycheck. We can return a paycheck. But because we made this method abstract, there's a couple things. Number one, there's no method body like there is here. We just put in this little semicolon. And what that means is this method has to be implemented by a subclass. Okay? Right? So again, that means we need an hourly employee or we need a commission employee to implement this method. So if I go up to the top here, it's underlining employee. And the reason is it says if I hover over this, get it to stay, employee is not abstract and it does not override an abstract method get paycheck. So what it's saying is you have a method here that's abstract, meaning it needs to be implemented by a subclass, and yet you're still allowing or trying to create a situation where an employee could be created, which could cause problems. So what I'm going to do, I'll just follow the advice. I'm going to left click on the light bulb, and I'm going to make the class abstract, public abstract class. Hit save. So now my employee class is fine, but you see this class, right, where we've created our employees, it no longer allows us to create an employee. It says employee is abstract. It cannot be instantiated. And that means you cannot create a new instance of an employee because it is abstract. Okay, so let's do a little commit here. Team commit, and I'll say added employee and paycheck. And you should always, in your commit message, add in something useful and say commit team remote push. All right. So most of you probably either you're currently working in a job where you're paid by the hour, or you've had a job where you're paid by the hour. So let's create that next. So I'm going to go in the same package here, say Java class hourly employee. Zoom in a bit. And as you can see in our diagram, an hourly employee extends the employee class, meaning I want this to inherit everything in this class and then specialize it, add some specialized features. So what I'm going to say is public class employee, it extends the employee class. When I write that, I get a little underlined squiggly here, and I say, because it's got abstract methods, it's trying to force us to implement that method. So I'll do that. So remember, this is the pattern we set in the employee class. It has to return a paycheck, and it has to be called get paycheck. And you can see by default, it throws an exception because we haven't created the code for this yet. Now we have another problem. The other problem is the whole thing's underlined now. And if I go to my light bulb, it says, you know, the constructor in the employee class cannot be given to given types. We haven't created a constructor yet, so there's no way to set the attributes of an employee, which require a first name, a last name, social insurance number, and a date of birth, right? So it says required string int local date, but it found no arguments. So we can add a constructor here, right? So an hourly employee requires, I'm just gonna hit enter here so that you can see it all on the screen at once. And maybe we'll make this a little smaller. Okay, let's do that. So what we're saying here is an hourly employee requires a first name, a last name, a social insurance number, and date of birth at minimum. And what it'll do is as soon as it gets that information, it calls the super or the super class, and it passes in a first name, a last name, social insurance number, and date of birth, right? So this, our employee class, is the super class. So when I create an hourly employee, the first thing I need to do is ensure these are all set. And that's what's happening here. It's saying super class, super, insert first name, last name, social insurance number, and date of birth. But an hourly employee has to have an hourly rate as well. We need some attributes that are unique. So let's add those now. So say private double hourly rate and hours worked. So we can track the amount of time that someone has worked. So when someone's first hired, the amount of hours they've worked is 0. So we can say hours worked equals 0. Now for the hourly rate, that's whatever you agree with your employer. So we need a way to set that. So when we create the new hourly employee, let's add an attribute here. Say double, I'll call it the hourly rate. And then in here, I'll create a method called set hourly rate. That's that in. Now we need another idea. I mean, labor laws are different all around the world, but here in Canada, there is one that sets the minimum wage. So I'm going to say private final double minimum wage equals. Now it's $11.40. And then when we create our set hourly rate method, we can use this this constant as a reference point. So we say if rate is less than minimum wage, right? So that means it's an invalid amount. Throw new This will give our users a message: hourly rate must be above the minimum wage. Otherwise, we can say this dot, or we can just say hourly rate is the rate. Okay, so I don't have any topside validation. I'm just making sure we at least pay the minimum. Okay, so our hourly employee now has the ability to be constructed. We have the ability to set the hourly rate. So what else should we be able to do? We need methods to get the hours worked and to add the hours worked. So this method will allow a user or an employee to so here we'll just do a simple little validation. Again, I encourage you, make sure your variable names really reflect what's inside of them. So in this case, these represent the new hours worked. So these are hours not previously recorded, right? So I'm going to call it the new hours worked. And I'll say if, I mean, again, we should make sure this is at least a positive number. It's going to be greater than 0. And let's see here, in a given day, probably should be less than, let's say, 15 hours. Maybe that's our store policy. If that's true, then I can say hours worked, whatever was in there before, plus new hours worked. Otherwise, it must be invalid. So say inform our user. Wrap it around. Oops. Okay, so now we have the ability to set the pay rate. We have the ability to add hours worked. We can add in our getters and setters. So let's get those two things. And then we have to create this paycheck. So we get rid of this default code that was in here. Now let's get our paycheck. So first thing is we need to figure out how much money did the person earn. So I'm going to say double amount equals the hours worked times the hourly rate. Right, so that's the standard formula for most of you. Then everything else we already know. So we can create a paycheck. So I'm going to say paycheck, new pay equals new paycheck. In here, let's add in, we have to add in the person's name. So I can say super, right, which is going to give me the first and last name of our employee class. And then I have the pay amount. And then some memos. So let's say hourly employee paid. Throw out the hours worked. The last thing we're going to do is return this paycheck, right? So return new pay. Okay, so now we have a nice ability to get paid. Let's go test it. Hit save. And if I come back in here now, remember we couldn't create these employee objects because these are abstract. But now we've created hourly employee. So we can create hourly employees now. So I'm going to say hourly employee, employee number 1. And it's still going to complain because what it's expecting here is, let me just hover over this slow enough. There we go. You can see it requires a first name, a last name, an integer, local date, and then a double. But what it found was first name, last name, social insurance number, and a date. It didn't find a double, didn't find the pay rate. So we need to add that information in. So let's see. Fred can earn, let's say, $23 an hour and 10 cents, 12 cents. Okay. And we'll do the same with our second employee. So we'll make them an hourly employee. And then we're going to give them a pay amount of, let's see, Barney's always a little behind Fred, so we'll make it $15.87. So if we run our program now, hit the run button here. This is our first employee, is Fred Flintstone, the employee number, right? So we can see that the call to the toString method still works. And let's do employee 1. Now we can add the hours worked. So let's say he worked 13 hours one day, and he worked 4 hours the next day. And employee 2 put in some hours too. So maybe hours and 10 hours. So now I can create the paychecks for these two individuals. So I can say system.out F paycheck for first employee is paycheck amount. So we'll say employee 1, employee 1, get your paycheck. And then we'll do the same thing, but this time we'll use employee 2, and we'll obviously see different results. And do a couple things first. Well, let's run it. What we'll see is our paychecks don't print out very nicely, and then we can fix that. And some new line characters as well here. To run this, we see the paycheck for Fred Flintstone. The employee number is, and then we see our paycheck doesn't get represented that well. So let's get rid of the employee number stuff, and then we'll refine our paycheck. So again, the idea with this get paycheck is this whole piece here returns a paycheck object, and then what's happening is it's automatically calling this toString method, which is getting from the object class. But we don't want to get it from the object class. We want to get it from the paycheck class. So let's go in here and create our own method. Our return type is string. The name of the method has to be toString. Here, I'm going to do something a little fancy. I'm going to say return string format. And here I can use the same type of structures as we did with printf. So I could say name, get the employee name, and then I could say the amount. And I can format the amount of decimal places. And I could say, I don't know, check number. Get number. What happens is each of these little percent signs is a placeholder. So the first one's expecting a string. So here I can say, I'll get the employee name, right? So here I can say employee name. And the next thing we're looking for is the amount, right? So %.2f means give me a floating point number with 2 decimal places, right? So that's called the amount. The last thing here was the check number. So I'll just say check number. It's able to keep you straight because the order is important, and we're using commas to separate these different arguments, okay? So this returns string with this format. I'm going to go back into the employee class as well, and I'm going to get rid of, right now, the idea of adding in the employee number. We'll just return first and last name. So if we rerun, now we can see first employee is Fred, second employee is Barney. The paycheck for Fred is the name, so there's the name on the paycheck. The amount's $392.04. Oh, check number is 0. And then looks like Barney's got to pay, but the check is also 0. So we've got a problem here, and this is the nice thing about the way we've structured it. If the check doesn't have a number, we need to go back to the paycheck class and figure out what's going on. So if I go back here, I never actually set the check number. So here's our constructor, but we don't set the check number. I can try that again now. So we'll run our program. Now we can see our check numbers are populated, the amounts are calculated, and we have the names of our different employees. So here we have an employee class, and we've extended it for the hour employee. Now we're going to do pretty much the exact same thing for the commission-based employee. We're going to create it such that it extends the employee class as well, and we'll see that these different instances are all instances of employees, but they have different ways of calculating their pay. So I'm going to do this one. Let's go back here. We'll add in new Java class, and I'm going to call it commission employee. Okay, and here again, we're going to say it extends the employee class. And all our abstract methods. Make sure we have a valid constructor. And let's go back to our design. So here we need to track monthly sales and a commission rate. So okay. Now monthly sales is easy. We have an employee, they have not sold anything, so their monthly sales is 0. The commission rate, we have to pass that information in. So let's go, oops. Let's make this a little easier for everyone to see. Okay, so here's our constructor. We expect a first name, a last name, social insurance number, date of birth, and a commission rate. Maybe we'll make sure our commission rate's somewhere between 1 and 40. And my method name reflects what we're doing in here, in which case we're setting the commission rate, so that's exactly what I've called it. We expect a double to be populated in. I'll call this new commission rate. So if it's greater than or equal to 1, and if it's less than or equal to 40, it's a valid rate. So I can say commission rate, new commission rate. If that's not the case, then let's inform our user. So we're going to throw new legal argument exception. Add some get methods. So I can just right click, getter, generate. Right. I spell these different? Aha. Set commission rate. There we go. So we need to be able to add in some monthly sales. And we need to validate if the new sales amount is positive. So if a new sales amount greater than 0, otherwise we need to inform the user that something went wrong. And then, so now we have the ability to add sales. We have the ability to create a new commission-based employee right here. So again, just like we had with the hourly employee, when we create a commission employee, because they are also part of the employee class, right? So commission employee, oops, employee is an employee. So we have to call the superclass to create the employee, and then we add in the specialized features. So the last thing we need to do here is create the paycheck. So let's do that. So the amount is going to be equal to commission rate. Remember, even though we might express commissions as 5%, what 5% really is 0.05. And the way to get that is divide by 100. So I'm going to say commission rate divided by 100 times sales. And then our paycheck. So we'll say paycheck, new pay equals new paycheck, and expects the person's name. So I'm going to say super.toString, which gives me their name. And then we add in the pay amount. And I'm going to add in for a memo. The memo here is going to say commission sales, commissions. We'll reset the monthly sales. And return the new pay. Okay, so what happened there? Let's go back. So our check, maybe we'll actually add the memo information as well. So paycheck. So when we do our toString, we'll add in memo. Let's put from a memo. And we'll say. Right, so we'll add in our memo so we can see the different types of employees. And let's test it out here. We'll create another type of employee. So employee number 3 is a commissioned employee. And a little bit younger than the others. And commission rate, let's say, is 5%. 3, let's add in some sales, so maybe he sold. Few things here. Okay. And then let's print out the paycheck. So we'll say There we go. And I'll just bring iterate it again. So here, when I click on Get Paycheck, see again, you can see it's calling the commission employee to get the paycheck, okay? Because that's the class where that's defined. So if you put in a new line character here as well, and we run this, paycheck for employee 3, the name's Bam Bam Rubble, the amount's going to be for $1,068.48. See, it's check number 3, and the memo is it's commissions. And you can see for the hourly employee, right? Hourly employee is paid. You can see the memos are different between the different classes. So there you have it. We've created an employee class, and then we've created 2 subclasses. One's called hourly employee, another one's called commission employee. These are relationships, and these have a has a relationship for paychecks. So paychecks are part of these employees. And where we're going to go with this is the model of our class. Okay, so we have a model to represent our employees, and where we're going to go is to this idea of a model, a view, and a controller. And we'll get into it in much more detail in a future class, but the idea is we've created the model, so how we store data, structure of that data, the rules for that type of data, all the employee information. And then what we're going to do is create views. And in between the views is this thing called a controller that will talk with the model to get information, will send information into the model, it'll get information out of the model, and it'll send that information to the view. And so for future, what it's going to look like if we launch it is, for example, if we want to create an hourly employee, we'd add in first name, last name, social insurance number. We have this date picker to pick the date of birth, and we'd set an hourly rate. And then when we have a commission-based employee, we would do the same thing, but we'd have a commission rate, right? So just like what we did with our models, right? If we go back to here, oops. If we go back to here, we can see we created a new instance of employee where we received first name, a last name, social insurance number, and a date. And we'll be able to get that from our GUI. So that's where we're headed. I hope you enjoyed this class, and we will see you next week.